here we go. In this one, a candy shop charges $4 per pound for dark chocolate covered almonds, and $6 per pound for dark chocolate covered cashews. How much of each should, you don't have to include the when you read this, by the way. How much of each should be mixed to make a 10-pound blend that sells for $5.40 per pound? Oh, yeah, so you have a $4 per pound candy and a $6 per pound candy. You should be able to mix them in such a way that you get a price that's in between per pound, right? In between $4 and $6. So it's hard to draw a picture of this, isn't it? And I suppose you could make up a table, but then you often, if you make up a table for this one, you often get it confused with the tic-tac-toe chart from the last problem, so I don't do that. Different books do it different ways. If you read your book, I'm sure your author does it differently. But on these mixture problems, I just suggest naming your unknowns appropriately. So I don't get too creative here. I'm going to let X equal, how much of the first type. But I do have some suggestions here. Write down the units. Get in the habit of writing down the units of what it is you're measuring. And you'll understand the problem better if you do that. So this is part of Polya's first step. How are we measuring how much candy we have? Are we going by volume? Big hint, no. We're going by weight, pounds, right? In the grocery store, you are often charged per pound when you get fruit or candy or whatever. So we should say pounds of, X equals pounds of dark chocolate. Or first candy, I don't really care. If you want to shorten it, since they're different kinds of candy, you could say almonds. It's just got to be clear what you mean, and you got to put the units of measure in it, okay? So that's about as short as I can make it. X equals pounds of almonds. Okay, what does Y equal? I don't know why I went to green there. So what's the units? Still pound. Oh, if you want, you could use ditto marks here. Pounds of cashews would be the shortest way to write it. Yeah, it's dark chocolate covered cashews, but as long as you put enough in there that anybody reading it would understand what you're doing, I'm happy. Okay? So I was specific with the units of measure. That's what I want you to do. That's all part of step 1 in Polya's 4 steps of problem solving. Step 2, we want to set up a system of equations involving X and Y that we could use to solve, that we could solve in order to answer the question, I should say. In these mixture problems, there's always almost a free equation. Add the variables together. It should equal something. What does X plus Y equal? So X plus Y is equal to, it's a 10-pound blend. Now this should make perfect sense. You're adding pounds to pounds, and you should get pounds, right? Okay, when you're mixing things together, you're adding them together, right? So you're going to add X amount of almonds, Y amount of cashews, and you want, those are both measured in pounds, you want 10 pounds altogether. Does that first equation make sense to you? Okay. So X plus Y is equal to 10. And in most of the mixture problems, you're going to get an equation where if you just add the unknowns together, it's going to equal whatever number that the problem gives you. Whatever appropriate number that the problem gives you. So that's one equation. We need to come up with another equation though, right? Well, let's do one that involves cost. If you have X pounds of dark chocolate covered almonds, how much does that cost? X times 4. Good. So if you had 2 pounds, you'd multiply by $4, right? It cost $8. If you have X pounds, you'd still multiply by $4 to get the total cost. Does that make sense? So let me label this so that you understand where I got this. So 4X would be, okay, it's $4 per pound for the dark chocolate covered almonds, and it's X pounds. So this would be the cost of X pounds of almonds. 4 times X. Does that make sense to you? Okay. Plus, can you get me something similar for Y? So it costs $6 per pound for the cashews. And if you have Y pounds of cashews, the total cost should be 6 times Y. Does that make sense? If it doesn't, use numbers. You guys are great with numbers. Y is a number. Think of it that way. But use specific numbers if you're confused. If you have, I don't know why you'd want 2 pounds of chocolate. Okay, that's a lot. Maybe you're buying it for your whole family. 2 pounds of chocolate-covered cashews, how much is it going to cost you? $6 per pound, 2 pounds, $12. You guys can do that like that, especially you guys that go shopping at the grocery store. Why would it be any difference if you had Y pounds, the operation? It won't. It would be 6 times Y. Y pounds, $6 per pound, 6 times Y. Does that make sense? So it's the unknowns that really mess with our minds, right? But you have to get in the habit of thinking of Y as a number, and it won't be so scary. And it's a number, and it's measured in pounds. That's why it's so important to name your unknowns in terms of the units of measure. Okay, we want a 10-pound mixture, but you can't set it equal to 10. That's just pounds. This is in money, right? So you're adding 4x. That's in dollars, right? 6y is in dollars. So you should get something in dollars on the other side of the equal sign. You know it's 10 pounds of candy, but how much do you want the 10 pounds to cost? $5.40. So it's going to be 10 times $5.40, or, well, actually, that's fine. I'll leave it that way. I'll make it 5.4 instead of 540. Same thing. So just to make this totally clear then, 10 times 540 is the cost of the 10 lb, 10-pound mixture. The units should match up on the left side and the right side. If you just left it as 10 on the right side, that's in pounds. The left side, it's in dollars. That doesn't make sense to use an equal sign there. So you got to get the cost of the 10 pounds of the mix. Okay, does that second equation make sense? Okay, let me remind you of the second method for solving systems of 2 equations, 2 unknowns. It's called elimination. So let me clean up that second equation. So the first equation is going to remain x plus y equals 10. The second equation is 4x plus 6y equals, what's 10 times 5.4? 54. Okay, the elimination method. So there's a step to do first. Do you remember what it is? Let's say we want to eliminate x just for the sake of argument. We could multiply the first equation by, no, multiplying by 0 just gives you 0 equals 0. So the idea behind the elimination method is if we want to eliminate x, we'd like to get the opposite up here. We'd like to get the opposite of what we have here. So instead of a 4x up here, we would like a negative 4x. And so how do we do that? What do we do to the first equation? So you multiply the left side by negative 4, but balance principle says you have to multiply the right side by negative 4 as well. Okay, so multiply through by negative 4, what do you get? I'm going to write the result down here. So negative 4x minus 4y equals negative 40. So that equation in green right there is the first equation multiplied through by let me fix that. I don't know where that came from. Negative 40. I said negative 40 and I wrote negative 14. That's great. Okay. So that second equation comes from multiplying through the top equation by negative 4. And then we just add the equations together and eliminate the x's, right? Everybody remember that? Yeah. Okay. So we add those together. We get, what do we get on the left side? What's 6y plus a negative 4y? 2y. 54 plus negative 40? 14. 2y equals 14. What does y have to equal? 7. 7 what? Go back. This is why you name your unknowns, because the problem's so long you forget what it equals in the middle of it, right? So it's pounds. Oh, 7 pounds of the second type of candy, cashews, right? So 7 lbs. And then can we get x? Remember, one of the equations is x plus y equals 10. So couldn't we just substitute into the second well, actually it was the first equation originally. That's y. Couldn't we just substitute that in there and solve for x? Yeah? So if we do that, we get x plus 7 is equal to 10. So what does x have to equal? Subtract 7 from both sides, x equals 3 pounds. Can you summarize the results here? So I'll say, so the mix contains 3 lbs of, I'll just say almonds for short. And what was the other one? 7 lbs of cashews.